Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is the ninth video, guys, which simply means I'm doing question number 9, and please do expect a total number of 11 videos whereby I'm tackling past exam question papers, and I'm only focusing on Doppler effect. It's very important for you guys to watch these videos because I'll be helping you on how to approach exam-like questions. And I believe that knowing how to approach exam-like questions will give you an edge whenever you write your examinations. So please do share the video to your peers so that they might have that edge as well. Question 9. We are told that a learner in a car which is moving at a constant speed of 10 meters per second along a straight horizontal road records the frequency of the sound emitted by a stationary source. Okay, I now know that the velocity of the listener is 10 meters per second and the velocity of the source is 0 meters per second. Okay, the learner then repeats the recording of the frequency of the sound when the car travels at a new constant speed of 20 meters per second. Oh, okay. And then we are told that the graph below shows the graph below, which is not drawn to scale, is obtained from the results. This is actually, guys, the frequency of the source. Are you together? This is the frequency of the source. And whenever the learner is moving at a speed of 10 meters per second, the learner will detect this amount of frequency. Are you together? And when the learner is moving at a constant speed of 20 meters per second, the learner will detect that amount of frequency. Are you together? So what I'm saying is that as the learner is moving at a certain speed, the learner will detect a lower frequency, which simply means that the learner which is in a moving car, they are moving away from our stationary source. The learner is moving away from our stationary source. Why? Because the learner observes a lower amount of frequency. Okay, now let's answer the questions. Firstly, they want us to state Doppler effect. Doppler effect is the apparent change in the observed frequency of the source as a result of the relative motion between the source and the observer. Doppler effect is the apparent change in the frequency of the source as a result of relative motion between the source and the observer. Okay. And then 6.2, we are told to use the graph to answer the following questions. Write down the frequency of the sound emitted by the stationary source. The sound emitted by the stationary source is 700 hertz. The frequency of sound emitted by the stationary source, we must give a reason for our answer. It is 7,000. Why? Because the learner has not yet moved whenever the learner records this amount of frequency over there. Are you together? The learner has not yet moved. The learner's speed is still 0 meters per second. So that means the learner and the source are still at the same position. As soon as the learner starts moving, the learner will then start to record the frequency, and hence we have these two other frequencies that are there. Okay, then now we are being asked, in which direction is the car moving relative to the source? Choose from towards or away. Remember that we said the car is moving away from the source. Why? Because as the car moves, the learner will detect the frequency which is lower than that of the source. Then now they want us to calculate the speed of sound in air. Let's write down the information we have. Over here, guys, we can use any of the information. It's either you can use the information when the learner was moving at 10 meters per second, or use the information where the learner was moving at 20 meters per second. You will still get the same answer. Let's just do that. The frequency of the listener, the frequency detected, if we use 10 meters per second, we'll simply have 679.1 hertz, and then the frequency of the source is 700 hertz. The velocity of the listener, that's 10 meters per second. Velocity of the source is stationary, 0 meters per second, and the speed of sound, that's what we are looking for. You'll simply say FL is equals to V plus or minus VL all over V plus or minus VS multiplied by Fs. Since our source is stationary, on our denominator we'll simply have the speed of sound only. Why? Because this guy over there is equals to 0. And then at the numerator we will have V and also the velocity of the listener times Fs is equals to Fl. Now I'm wondering, which sign am I supposed to substitute over there? Is it a plus or minus? Remember that, guys, my listener is moving away from the source. So if the listener is moving away from the source, I'll simply put a minus over there. Are we together? It's a minus over there. So the frequency of the listener is simply 679.1. I'm looking for that V over there, minus 10 meters per second all over V multiplied by the frequency of the source, which is 700. All I have to do now is to cross multiply. I'll simply have, let me use a different color, 679.1 multiplied by V is equals to V times minus 10 all multiplied by 700. This will give me 679.1 times V is equals to 100 V minus 700. Whenever I take the, no, it's not 700, man. 700 multiplied by 10 is minus. Are you together? It's minus 7. It's minus 7,000 rather. Minus 7,000, and then all I have to do is to take the 700 to the other side. I'll simply have 700 minus 679.1. This will give me negative 20.9 times V is equal to negative 7,000. Divide both sides by negative 20.9. Then the speed of sound in air is just 334.93 meters per second. That's how, guys, we're supposed to calculate the speed of sound in air. Was that the last answer? Oh, yeah, it was. The speed of sound, it was 334.93 meters per second. Yeah, that's how, guys, you're supposed to tackle this question over there. I really hope that the video helped you out. Just stay tuned, guys, and wait for more videos. Thank you.